Okay, so this is 6.1 from the textbook. Chapter 6 is all about trig identities. I want to make sure I spell this right. Trig identities. Okay, so trig identity, just so you guys know what they are. And when I say trig, I mean trigonometric.
This unit that's supposed to be like way harder than all the other ones.
Tends to be one that people tend to not like. A trigonometric identity is a statement or formula that is true throughout. Okay. Throughout. Okay. So just like Pythagoras, a squared plus b squared equals c squared, we have other ones now that work with trigonometry that we can use. All right. So let's just go back to the unit circle for a second. With our unit circle that we covered in chapter 4 of the textbook. That's a perfectly square circle. I should have drew the circle first. We have radius of 1, right?
Yes.
R equals 1. And we also know that our x and y values are actually our sine and cosine values, right? We know that our y value equals sine, and our x value equals cosine, right? We can all agree on that? Jenna, we're cool? Okay, great. So what we know about this stuff now is we can start to manipulate it and use it in other ways. So for example, what we can do is, let's start with, we remember that x squared plus y squared equals r squared, right? We learned that in pre-calc 20. What we can do now is, based on our unit circle, we can substitute cosine in for x and sine in for y. So we can actually say this. Cosine squared of an angle plus sine squared of an angle equals 1. Okay? Now, this is your first identity right here. Your very first trigonomic identity. This is the Pythagoras identity.
From this side. Where have you been? I was going, I don't know.
What's that? Yeah. Everything that we're going to talk about here is based on unit circle values.
Okay.
Okay? We call this the Pythagorean theory identity. Okay? Now, just like a regular Pythagoras, where we can, if we want to solve for, the non-hypotenuse side, we can move stuff over and solve it. We can manipulate this as well. So you can take this and you can bring cosine over to the other side. You could say sine squared equals 1 minus cosine squared. Okay, I just subtracted it to the other side. Or vice versa, I could say cosine squared equals minus sine squared. Okay, and this is true for all values on the unit circle. If you take any value or any angle on the unit circle and take those coordinates and square them and add them together, you're going to get 1. Okay? Promise.
Okay.
All right, so that's your first identity. Now, when we get going here, I'll give you an identity sheet with all the identities that we're going to use. Just like in physics, I'll give you the formula sheet. You only are given this one here. You need to know how to manipulate to get these ones here.
Okay. Yeah.
Fair?
Yeah.
Okay. Now, next one we talked about.
Do we get these identities like for the tests?
Absolutely. I'm not a monster. Okay. Now, the next one we talked about, remember how we learned also that we learned that tan of an angle is y over x, right? Right, we can actually say now, because we know that y is sine and x is cosine, the tangent of an angle equals when we've done this before. This one shouldn't be earth-shattering, right? And then we also learned the inverse, or sorry, the reciprocal of tangent was cotangent. So we know that cotangent equals so far so good?
Yeah.
All right, cool. You guys are doing great. Now there's other ones as well. Yeah. Other ones to be aware of. We know that cosecant of an angle is just the reciprocal of sine. And we know that cosine, oh, wrong one. We know that secant of an angle is 1 over cosine. Right? We're okay with those?
Yeah.
That's what they mean by reciprocal. You just put it over 1.
Yeah.
Okay? Now, you can manipulate these ones if you want, but there's no real point, because if you bring this over to the other side, you're going to get cosecant times sine equals 1, which is what you get whenever you multiply a reciprocal, or a number n is reciprocal.
Yeah.
You'll always get 1. Okay? So, these are identities. Now, the reason I'm showing you this stuff is because you'll use this so much in the real world. Very little tonight. You'll use it in first year calculus. Yeah, in university. Are you in university? So then, maybe you'll use it.
No, I'd be going to college.
College? Okay. You might, if you take like a first year math class or something, you might see this as well. What the point of these are. Big whoop, right? Oh, that's cool. Sine squared plus cosine squared equals 1. What's the point of this? The point of it is to now take more complicated trig equations and simplify them. All right? So that's what we're going to be doing here.
So they're going to give us a complicated equation. Break it down into something we can actually understand using abstract.
Very good, yes. How they work is they give you something super complicated on one side, and they're going to say, prove that this equals this, and they give you what it wants to be. So you take the complicated part, because there's lots to work with there, there's lots of moving pieces, and you start breaking it down and making it simpler. Okay? So what's nice is, like, with this stuff, there's no real right way of doing something. You can do it any way you want. Just, you got to get the right answer. What's nice is it gives you the answer that you need.
So like the same way that you can use like different equations in physics to find the same answer. You use different of these identities to solve those.
Yes. Yes. I think you get like 20.
That's 20.
Yeah, I teach you 20. 21? 24? It used to be like 30.
Great, now I'm gonna have to double check my answer 20 times.
There's no way of checking it. You just hopefully that's right. Do I have an old C30 textbook here? Oh, I do.
We used to call it C30. Why?
This is what we used to teach.
There you
I better pause this for a sec so I'm not just rambling.
Didn't there used to be like math and math 30 and that's it?
Where's the recorder? Oh. So a possible example that you might see is something like this. Cotangent x divided by cosecant. Oh, I hate how the textbook uses x's. Sorry.
It should just mean the same thing as theta, right?
Yeah. Normally I put theta. Sorry, I just writing it out of the textbook. I didn't even catch it. Equals 1. That's interesting. That's the spirit. Sour face. Ooh.
What's this supposed to mean?
Well, it means what I'm going to try to do is prove that this big, beautiful trig identity in all its...
Basically, all of our questions, basically, we just don't know if the textbook is lying to us or telling us the truth.
No, they always work. There's not one that won't work, but we need to show it.
Why?
Because simplifying these things makes your life easier down the road.
What would you use this stuff for?
Some complicated physics or engineering type questions. Once again, this course is designed for people who are thinking engineering, physics, some kind of science. Oh yeah.
That's
So.
not this course because I'm not going
Well, there you go.
Except I don't want to be a rocket scientist, which is the problem. I probably would still want to be most of this rocket science.
Either way, okay, let's look at this. So what's nice about this is, here's what you have right here. This is what I'm trying to get to.
Okay.
So I need to solve to that. So I know the answer, I just need to get there now.
Sweet.
All right? So it's kind of backwards. Like normally I've always wanted to see the answer you get. Now I want to see how you get there. Okay? Because I've given you the answer. So let's look at some of this stuff. And I got a cotangent on top. I have a cosecant times cosine on the denominator. Okay. Now, this is really going to break your brain because there's more than one way to do this. I'm going to look at this part. I'm going to look at the denominator first. Okay, cosecant here. I know cosecant is actually 1 over sine. So I have 1 over sine times cosine, right? Because it's still cosine here. Yeah, oh sorry, and then this is all over cotangent.
Okay.
Okay, we'll leave it like that. So now, I'm going to multiply these two together. With fractions, right? You just multiply straight across? You need to really Sure. Right, so if I do that. Very good. Holy moly, you guys are naturals.
Oh, so that's cotangent over cotangent. That's equal.
Yeah, so now this is going to be cotangent x all over cosine x over sine x. Now I told you before, cosine over sine is actually cotangent. Sine over cosine is tan.
Oh.
Okay, so now I have cotangent on top, and I have a cotangent on the bottom. What's anything divided by itself? Boom. Very good, you guys. That was great. Your first trig identity, and you guys are pretty much like solving it on your own.
Right. That's so concerned with these.
And more importantly, we're not having a meltdown. That's key for first aid identities.
They're only confusing.
I'm fine as long as there's no-
Okay. You guys are doing really good.
All we did was take something that we knew equaled 1 and made it more simplified.
Exactly. Just don't ask the whys, just surrender to the process.
Mm-hmm.
Oh, forget the non-permissible values. Well, just like what can't you put in for an x?
I know what it is, but like.
So like, if you look here at your non-permissible values,
Have to be greater than.
like cosine and cosecant can equal 0, and cosine can equal 0. And where does cosine equal 0? Pi over 2 and 3 pi over 2. Yeah.
And then for cosecant, it would be pi and 2 pi.
No, that would be, they'd be undefined. Sine 0 there, right?
Yeah.
The reciprocal of 0 is undefined. So there is nothing for this. No.
So it's not 0. So the non-permissible value isn't 0. It's nothing. So it has no.
Oh wait, could it be undefined? I guess it could be pi and 2 pi. Oh wait, no, it's fine. Yeah, you're good. There is nothing for cosecant. Yeah. So these would be your non-permissible values here.
Wait, why are we? What is that?
Don't worry about it.
It's just the non-permissible values. Do you remember what those are? Values that you can't put in for x. All right. If I put 0, if I get a 0 on the bottom here, what do I have? Error.
Do we
Right.
need to know that for this class?
Oh, you should be aware of it. Just have an idea. I don't know. Maybe. Am I making you nervous?
Oh, yeah.
You seem very tense, Brennan.
That's because I wasn't paying attention, so I was trying to finish my assignment, but I don't want to do it.
So when you say you can't put it in for X, you can't put it in for,
At least you're honest. I can't be mad at you for being honest with. Say that again.
when you can't put it in for X, you can't put it in for. It's called
The unit circle?
no, it's like.
Oh, theta.
Theta.
Yeah. That's okay.
Okay, no one.
Let's try another one. I have always liked these things because they're kind of like a puzzle. Okay, Brennan, pay attention. Let's go cotangent squared plus 1 equals cosecant squared.
And so cosecant squared plus cosecant squared minus cosecant
Where
squared.
does find a common denominator?
Oh, say that again.
Wait, actually, the blue was
Yeah, very good. Brennan, you're like the Rain Man of...
Denominator would be sine, but not be
Right, okay.
1 over. And then it would be.
General tip for identities, always take the side that has more to work on. The more complicated side, because then there's more for you to manipulate. Okay, so I'm going to take cotangent squared plus 1. Cotangent, we know, is cosine over sine, right?
Yeah.
Squared, squared. That's what it looks like squared. You got to have both those values squared. Plus, now 1. If we want to add these together, what do I need? Common denominator. So what's the common denominator? So this is 1 over 1.
Sine over sine. Sine squared over sine squared.
Sine squared over sine squared. Very good. Does that make sense, you guys?
Yeah.
Jenna?
I don't know.
You don't know yet? It's kind of weird, right? This should be weird. You guys are doing really good. Kind of weird though, right? But not bad. What's that?
Wait,
Wait, what? What?
I don't know the word square.
Why is squared on the square? Well, okay, if you multiply exponents, it's addition, so it'd be four.
Oh, but it already has the right. No.
Yeah. Yeah, don't worry, don't touch this side. Leave it alone.
Okay.
Remember, that's my answer.
Oh, yeah.
Okay,
I guess.
now, I have everything here with a common denominator, like Brendan said. So what I can do is write everything over that denominator, right?
Yes.
So now I have plus sine squared. Oh, Jenna, I'm going to put you on the spot here. What did I tell you cosine squared plus sine squared is? You shouldn't have this number.
I still don't know what you did at the beginning.
Okay, cool. Like here to here, I needed a common denominator to add these together, right? Like this is cosine squared over sine squared, right? And this is just 1. If I want to add fractions together, what do I need? I need a common denominator. So I times all this by sine squared. And that's where I got sine over sine. Anything divided by itself is always just going to be 1. That's good? Okay, excellent. Now, Jenna also told me cosine squared plus sine squared is 1.
And
1
over sine squared is secant.
Right, and we know, okay, cosecant is just 1 over sine. So 1 over sine squared is cosecant squared. Boom.
Okay.
That's gonna get about 14.
You don't know that.
We do know that actually. That's kind of how math has gone for the past 3 years.
Especially got like a whole page to write stuff down because it's just
Mr. Wilbur,
What, Chloe?
hey, when it doesn't, I just keep on forgetting little things.
Weird.
Yeah, okay.
Okay, just hold on. I just gotta get the assignment. I'm recording this, so shush.
Okay.
So on page 296. Now for 6C, it says to verify with pi over 4. Don't. All of these questions just solve with identities, okay?
Okay.
If you can. There's no shame in this. There's no shame in this if you can't get it right away. I'll shame you later though.
Like on the test.
Maybe.
is this being combined with unit 4?
Yeah. It's all trigonometry stuff.
Are you gonna do 3 units on one test?
Yeah, are we gonna go back and do unit 5 like that?
No, I'll do that separately.
Okay.
Unit 5, graphing trig equations, I can teach you guys that in a week. And then we'll just have a quiz. It's not hard.
Sure.
I can teach Arabic students that can barely speak English how to graph cosine, sine, and tangent. I can teach you to do it too.
Or they watch YouTube videos after you taught them.
They do.
No, think
Yeah.
like algebra. Sure. Algebra comes from the.
Very good.
I'm not even. I'm like that serious.
No, it's true. All our number systems, like the symbols for 1, 2, 3, 4, 5, 6, that's the Arabic numeral system.
Are you gonna stop
No.
the recording?
No, they're not.
Not necessarily. No one's good at math.
It was.
Bye.